So today I'll be attempting problem number 18. Notice I said attempting because, boy, do I get confused with this one. Alright, so just a reminder, when I have hiccups, 2, you can find this question booklet in a link posted below in the description box, and it also comes with the answer sheet so you can follow along with how the SOA chooses to answer it. Alright, number 18, 2 instruments are used to measure the height of a tower. The error made by the less accurate instrument is normal, we'll just say x of the less, and it's normal. I like to write everything out as I go through, with a mean of 0 and a standard deviation of 0.0056h. Why don't I write that? Because I've just been conditioned to write it as 0.0056h squared. We just write the var, which is variance. Alright, the error made by the more accurate, let's say x of more, which I'll probably turn to x of m, is also normal. Couldn't have guessed that. With a mean of 0 and standard deviation of 0.0044h squared. The error made from the 2 instruments are independent of each other. Calculate the probability that the average value of the 2 measuring instruments is within 0.005h of the height of the tower. So this is where I had gotten confused. So they said average, and I was thinking, oh, you mean like x bar? Like, is that what you meant by average? So I had solved the problem initially. Doing x bar, I'm like, okay, well, e of x bar is equal to e of x. So that all works. And then var of x bar. So I was doing, this is average plus x bar more. But let's read the question again, and let's see if we can figure out the hints, and that lets you know that this is not what they were looking for. I drop something every video, trust me. The average value of the 2 measurements is within 0.005h of the height of the tower. Okay? And it says the error made by the less accurate instrument. So this is the error. X is the error. X is not the value of the measurement. Okay? And usually I like to label what is my variable standing for. You have no idea why this is so important. Okay. The error made. And they want the average value. So what does that mean? What is the average? How do we find averages? Well, let's take it back to, I don't know, middle school or so, when you learned about averages and you always wanted to do a class average of test scores. Or they're like, oh, Sally got a 95, and Josh got an 84, and Tony got a 92. What's the average test score? And then you would add all these together, and then you would divide it by 3 because you used 3. Well, that's what they're looking for here. Thanks for letting us know. Alright, so they said the average. Well, what is the average of 2 things? It's just x of the less plus, that looks like x of I. X of the more divided by 2. And that's your average. That's the average they're looking for. They want average value. Alright, now it's within 0.005h. What does that mean? That means there's a 0.005h on this side, and there's a x of L plus x of m over 2 here. And then we have a 0.005h here. Okay? Don't forget your negative side. Because you can't be, you know, in between the same thing. That'd just be weird. Right? Here's 0.005 and you just want to be in between that line. You can't do that. So it's negative 0.005h to 0.005h. So now what are we going to do next? I'm going to multiply both sides by 2 because I'm that type of person. And just so, I'll throw you guys off, we got a negative 0.01 is less than or equal to x of L plus x of m less than or equal to 0.01h. Don't forget my h. Alright. Now, to solve something like this when it's normal, we know the CDF of a normal has that z thing, which is equal to x minus mu over the standard deviation. Okay, so this x is usually given off by this right over here or this right over here. Boom. And it's going to be subtracted by the mean over the standard deviation. But in this case, we have two things in the middle. So we need to find what is E of XL plus XM, which is simply equal to E of XL plus E of XM. Well, that was easy. Ding. All right, which is equal to 0 plus 0. So I'm going to put XL plus XM. I'm going to store this as K because I get tired of writing stuff. So we know the mu of K is equal to 0. Put it up here. So I'm going to delete that. Alright, now we need to know the variance of XL plus XM, which I am now calling K because I'm lazy and I don't want to write this out. We need the variance of K. And they told us that this is independent. So what do we know about something that's independent when it relates to variance of adding two things together? And you know what? Let me not call it K yet. Let me put it like this. So this is more intuitive. We know that this is equal to var XL plus var XM plus, and this is really important that you guys remember this because some problems are not going to be independent. 2AB, which AB would be this invisible one that's right here and this invisible one that's right here. But sometimes you do have a constant that you have to bring out there. So I'm just going to put it in for right now. 2AB covariance of x, y. Now, the covariance of x and y, xy, however you want to say it, when it's independent, it's equal to 0. And it's good to note that if two variables are independent, the covariance will always equal 0. Just because the covariance equals 0 does not mean it's independent. So let's say they gave you something that said, oh, this is covariance. X and Y have a covariance which equals to 0. Is it independent? Of course, they're not going to ask you that on the test, but just know that it works one way but not the other. So in this case, this equals 0 right here. Which means when you multiply 0 times 2 times A times whatever B is, you're going to have a 0. So that's why this part will cross out right here. Okay? So basically we're saying var XL plus XM is equal to the var of XL plus the var of XM, which is 0.00568 squared plus 0.0044h squared. Okay? And that is equal to some really long number. Alright. 0.1234507h squared. Alright. Now that we have everything we need, after much talking, 2, 3, 4, 5, 0, 7, 2h squared. We're ready to do this little z substitution thing. Oh, remember that we're in between 0.01. So Negative 0.01h less than or equal to k less than or equal to 0.01h. Alright. This right here, whenever you see this, this method always works. Never not seen it works. You want probability of 0.01h, don't know if I'm writing this right, minus the probability of negative 0.01h, okay? And whatever this subtraction here gives you is what your answer is going to be. So we're going to put in our stuff. 0.01h minus 0 divided by the square root, because we want the standard deviation at the bottom, not the variance, of 0.123450728 squared. Okay? Equals 0.01h divided by 0.12345, just for extra emphasis, h squared, goes down. Cross that out, cross that out. 0.01 divided by whatever this number is right here, which will equal 1.40413, which doesn't really matter because we're going to move this to the z table because we now have z at 1.40. And so we really don't need all those extra numbers. Now, I'm going to cut this video and I'm going to run and get my z-chart. Alright, z at 1.40, I got it equals to 0.9192. Alright, so now let's say we have plugged in this negative. This would just be a negative. So we'd have 1 minus z at 1.40. So I'm going to go through that one more time. I know I did that really quick. So I did this part. Now I'm doing this part, which is a negative 0.01h. So it's a negative 0.01h over that, which gives you just a negative 1.40. And then to get what that, when you have a negative sign right here, it's just 1 minus z at that. So 1 minus 0.9192 leaves you with 0.0808. So now I can erase some of this. Like my sound effects. We have 0.9192 minus 0.0808. Cross our fingers, hope for the best. Which leaves you with 0.8384. 0.84.